Hey guys, Mr. Ground here, 8.3, adding or subtracting rational expressions. In this one, when we add and subtract rational expressions, the problems are going to have factorable denominators that have something in common with the denominator of the other side. So if we throw this back to just basic fractions, let's say that I was trying to do something like 1/4 plus 1/8, right? They are different denominators, but there is a common factor between them, right? 8 is equal to 4 times 2. So rather than multiplying this side top and bottom by 4, this side top and bottom by 8, this is going to be easier if I create that common denominator by just multiplying this side by 2. And then I can convert that to 2 over 8, right? When I multiply that plus 1 over 8, and I get 3 over 8, right? Much simpler than if I multiplied this side by 8, this side by 4. Now they're in 30 seconds, and I have to reduce it again. All right, that's the same idea here. What we don't want to do to start this out, I'm going to do this in red. What I don't want to do is try to multiply this by the whole denominator here, x squared plus 3x minus 4 on top and bottom. You should never do that in this class. Not that there aren't math problems out there in a more advanced math class where you would have to do this, but not in this class, right? This is not very bueno. It's possible to do the problem like that, but it's super hard. All right, what we really want to do is try to find the least common denominator between them, and that involves factoring the denominator on this side. So multiplies to -4, adds to a +3. That is going to be +4 and -1, right? Well, now I can see both sides have an x plus 4. How can I make this side be the same denominator as this side? All I have to do is multiply it by that missing factor, x minus 1, right? That's going to be much simpler than if I tried to multiply this side by this denominator, this side by x plus 4. It'd be a huge mess. Okay, so now all I got to do, a little bit of distribution here. I've got a common denominator, so it's going to look pretty similar to the last video. Distribute the 2x in, we get 2x squared minus 2x. Everything is over plus 4 minus 1. And now I just have to combine my like terms and list my domain restrictions. Try to do these in standard form, right? We'll list the x squared first. Takes care of that. X minus 2x is minus 1x. And then I've got a minus 3 all over plus x plus 4, x minus 1. What are our domain restrictions? -4 and +1. Like that. Right, over here, similar, right? X plus 3 doesn't factor, but that x squared minus 9, that is our difference of squares, right? So now, this side has the x plus 3. To be common, it needs an x minus 3. Now we've got a common denominator. Bloop, bloop that in, and we get x squared minus 3x for this side. This side is just a plus -18 or just minus 18. And look at that, I don't even have to combine like terms on this one. What can't x equal? We could say either +3 and -3, or we could use plus minus 3. I like to use the plus minus 3, the plus minus whenever I can. So either way works. All right, give these a shot. Pause the video. And when you're ready, see how the master does it. All right, so again, another difference of squares, x plus 2, x minus 2. This side's got an x plus 2. It needs an x minus 2. And so now, a little distribution, x squared minus 2x. This side is just a minus 8. Another one where I didn't have to do anything after this. And we get another one where I can use the plus minus if I want for my domain restrictions. Make sure I put a slash through that to say that x can't equal plus or minus 2, rather than x equals plus minus 2. All right, and then over here, multiplies to 9, adds to 6. That's going to be a plus 3 and another plus 3. So now there's 2 of them. Now for these to be matching, it's got to, just because this is a plus 3 and you've got plus 3s over here doesn't mean that they match yet. It only matches if the number of them is the same. So if it's x plus 3 and another x plus 3, right, now they match. Distribute, we get x squared plus 3x plus this 2x plus 6 all over x plus 3, x plus 3. And now if I combine like terms, x squared, 3x plus 2x is plus 5x, and then a plus 6 all over x plus 3, x plus 3, and we get x cannot equal a negative 3. Now, you maybe looked at this one and you saw that there was a GCF here that I didn't factor out in the numerator. This actually could have reduced, and even at this point we could factor this and probably cancel out one of those x plus 3s, but I didn't do it because really the ones in this class that we want you to practice are the ones that end up like this or end up like something where it doesn't reduce. We're just trying to really kind of scratch the surface and do more of a basic concept of adding or subtracting these. It seems weird calling it basic because these are kind of a complicated looking type problem, but I think if we try to reduce this, if I can get students to get to this point and understand why they're getting here, I don't feel like at this point, we really need to simplify it further. I think it's just sort of piling on. We've already covered simplification, so it's not wrong if you do simplify it, but just know that it's not required.